Hello and welcome to where we'll be talking more about lines, specifically about slope and the application of slope. Now each line has a different direction, and we call that direction slope. Some have a very steep slope, some have a less steep slope, some have zero slope, and some lines have negative slopes. And we want to talk about this idea, but one thing that's very important is that we know that all lines are straight. Some people all tell me, "Hey, it's a straight line." Well, all lines are straight, right? If it's not straight, then in math we call it a curve. For example, this would be an example of a curve. I wanted to share with you a talk, a little story by President Uchtdorf about a matter of a few degrees. I really like this talk, but because he talks about the importance of lines and their directions, and being off just a little can be quite devastating. Let's go ahead and watch this, and then we'll get to the math.
In 1979, a large passenger jet with 257 people on board left New Zealand for a sightseeing flight to Antarctica and back. Unknown to the pilots, however, someone had modified the flight coordinates by a mere 2 degrees. This error placed the aircraft 28 miles to the east of where the pilots assumed they were. As they approached Antarctica, the pilots descended to a lower altitude to give the passengers a better look at the landscape. Although both were experienced pilots, neither had made this particular flight before, and they had no way of knowing that the incorrect coordinates had placed them directly in the path of Mount Erebus, an active volcano that rises from the frozen landscape to a height of more than 12,000 feet. As the pilots flew onward, the white of the snow and ice covering the volcano blended with the white of the clouds above, making it appear as though they were flying over flat ground. By the time the instruments sounded the warning that the ground was rising fast towards them, it was too late. The airplane crashed into the side of the volcano, killing everyone on board. It was a terrible tragedy brought on by a minor error, a matter of only a few degrees. Through years of serving the Lord in countless interviews, I have learned that the difference between happiness and misery in individuals, in marriages, and families often comes down to an error of only a few degrees. Is there a lesson for our lives in these examples? Small errors and minor drifts away from the doctrine of the gospel of Jesus Christ can bring sorrowful consequences into our lives. It is therefore of critical importance that we become self-disciplined enough to make early and decisive corrections to get back on the right track and not wait or hope that errors will somehow correct themselves. The longer we delay corrective action, the larger the needed changes become, and the longer it takes to get back on the correct course, even to the point where a disaster might be looming.
I really like this story, talking about how if you have a travel path that you're trying to go and you're just off by just a tad, if you only travel off course for just a short time, it's not that big of a deal. You can make a course correction and get back on path. However, the longer you're off that path, the greater the distance it can be to recover from that. I think as we look in our lives, we need to constantly make sure we're checking our instruments, that we consistently talk to our Heavenly Father and make sure we get confirmation from the Holy Ghost and make those course corrections. If we're off just a little, if we have a little sin here or there, we need to correct those immediately and get back on path. The longer you go without getting back and doing a course correction, the farther and farther away and harder it will be to get back on course. It's a great story, and we want to apply this idea also to the math that we're going to learn today. We're talking about slope, and we want to make sure that when we draw our lines, we're drawing them right, and that we're using that we're not off a couple degrees. So let's get to the math. Okay, so whenever you are given 2 points, we talked about that to find a line, you got to have 2 points. So if you're ever given 2 points for a line, you can always find the slope of that line given those 2 points. So let's take a look here. If I graph the point 4, 2, and I graph the point, 1, negative 2, we could find the slope of the line that goes through those 2 points. There's a couple ways to do it. First of all, let's define slope so that we know what we're talking about. Slope is the rise over the run of the line. In other words, it's the steepness. It's the steepness of the line. And some lines are steep, some lines are not very steep, and we need to be able to give them a quantifier, a value of how steep they are. So to do that, we always use rise over run. To do this, we could actually do it, since we have the graph, we could actually calculate the rise over run. In other words, if I started at this point down here, how high up, how much would I have to rise to get to the next point? Well, I would go 1, 2, 3, 4. I'd go up 4, so my rise is 4. And then my run, how far would I have to run, go across to get to the next point? I'd go 1, 2, 3, 4, 5. And so, again, the rise, or the slope of this, the rise over run, or the slope of this line, would be 4/5. So when you're given a graph, you can simply count the rise from one point and the run to another point to calculate the slope. That's one way to do it graphically. Now there's also an algebraic equation that we use, and this is the equation. Slope equals y2 minus y1 over x2 minus x1. Now you may say, whoa, what are the x's and the y's? Well, they simply come from the coordinates of the point. Remember, we said that this point is -1, -2. And this point, we said, was 4, 2. So if I wanted to calculate the slope using the equation, all we'd have to do is label the point. So this is my first point. So this would be x of my first point. This is the y of my first point. This up here was the x of my second point. And the 2 is the y of my second point. We then can simply plug those values in. And so y2 is right here. So I'd go 2 minus y1. y1 is right here, which is -2. All over x2. x2 was 4 minus x1, which was -1. So 2 minus a -2, those become plus, and it gets me 4. 4 minus a -1, those become plus, and I get 4/5. I get the same on each one. So there's 2 ways to calculate slope. Moral of the story here. You can do it graphically. If you're given a graph, or if you graph a line, you can pick 2 points and count the rise and the run to the next point. Or you can take those 2 points and plug them into this formula here, the y2 minus y1 over x2 minus x1 formula, this slope formula. Okay, so now it's your turn. Let's say that we have a point here at -6, 0, and a point here at 0, 6. I'd like you to find the slope of this line right there. I'd also like you to try another one. Let's say that you have, in the second one, we'd like you to find the slope between -2, -8, and 2, 10. Ooh, that's a steep line. 2, 10. Weak. Oh, I missed. And then for number 3, what we'd like you to do, I'm not going to give you the graph. I'm just going to give you 2 points. We'd like you to find the slope between -1, 5 and 2, -10. Go ahead and give these a try. Push the pause button. Give them a shot in your video notebook. And when you're ready to check your answer, we'll check them. Again, your goal here is to find the slope, the rise over the run, or the y2 minus y1 over x2 minus x1. Good luck. Okay, let's see how you did. Again, when you're given a graph, usually it's easy to just simply count the rise over run. So I'm going to start at this point, and I'm going to go up 1, 2, 3, 4, 5, 6. So I went up 6, and then 1, 2, 3, 4, 5, 6. I went over 6. So the rise is 6 over the run, which was 6, and 6 divided by 6 is simply 1. This line has a slope of 1. Okay, nice. Now we could do the same thing here if you wanted to. We could count up. Again, if I counted up, it would be, let's see, 8 to get to the y-axis, and then I've got to go up 10 more. So that's a rise of 18 if you counted all of them. Maybe a little small on your screen to count all those little things. And then my run was 1, 2, 3, 4. So rise 18, run is 4. And so my answer is 18 over 4. But remember, in this class and in any class, you should always simplify your fractions. I can divide the top by 2, divide the bottom by 2, and I get 9 halves for the slope. So the slope of that line is 9 halves. The slope of this line was 1. Now this one here, you could have graphed it. I don't know if that's what you did. I'm going to go ahead and use the formula for this one. You could have used the formula for any of these. I'm going to call this x1, and this y1. And this is x2 because it's my second point, and y2. So I'm going to use this formula here, y2 minus y1, which is 5, all over x2, which is 2, minus x1, which is negative 1. Okay, so negative 10 minus 5 is a negative 15. And 2 minus a negative 1, those become plus, is 3. Negative 15 over 3 is negative 5. So that has a slope of negative 5. Negative 5. Negative slope. So you can actually have negative slope. We better take a look at this idea of negative slope so that we understand what the difference is between positive slope. These two lines had positive slope, a positive 1, a positive 9 half. But this has negative slope. What does that look like? Let's take a look. Okay, so we're taking a look at negative slope. Now we found out that this line had a slope of negative 5. Let's look what it looks like. If I graph this, it'd be negative 1 and up 5 and 2, negative 10. So notice that this line goes, wow, I'm bad at drawing lines. This line goes down from left to right. So how we want to remember it is that as a line goes up from left to right, so this is going up from left to right, then it has positive slope. If it's going down from left to right, then that's an example of negative slope. Now there's two other situations that we could also have when doing slope, and that is, first of all, with this line is a horizontal line. And remember, we talked about horizontal lines being y equals some number. So if I gave you the line y equals 7, that's just a horizontal line at y equals 7. Now, horizontal lines have 0 slope. Their slope equals 0 because they have no rise. So if the rise is 0 and the run is, I mean, you can run as much as you want, 10, 0 divided by 10 is just going to be 0. So you need to remember that horizontal lines have a slope of 0. Now, what about vertical lines? We talked about vertical lines being x equals some number. So, for example, this one here, this line that's already graphed, would be x equals 3. So what's the slope of a vertical line? Now, that's a little complicated because the rise, well, you can rise as much as you want, rise a bunch, but there is no run. And so that means if we plugged it into the formula, we could rise, I don't know, 10, but the run would be 0. There's no way to run to the left or the right. And so 10 divided by 0 is, we don't know what 10 divided by 0 is. In fact, if you plug that into your calculator will freak out and be like, ah! It'll probably say error or something like that. So we say that vertical lines have undefined slope. undefined slope. Their slopes are undefined. You could also say infinite if you wanted to. The slope is an infinite amount of slope. Good. Now, some people from their high school days may have used the word no slope. In this class, you should never say no slope. That really doesn't make very much sense. We don't like this. Never say no slope. For a horizontal line, we're going to say that the slope is 0. And for a vertical line, we're going to say that it's undefined or infinite. Okay? Let's not say no slope. Ooh. Okay, here we go. There used to be an old TV show. I hardly remember it, but I remember the theme song for some reason about different strokes. Well, we want to play a little game here and do different slopes and talk about different slopes and see if you can find the different types of slopes, not different strokes, but different strokes, different slopes. Okay, good. Here we go. We have 6 graphical problems. We'd like you to look at all 6 of these graphs and find their slope. Okay, so to do this, you're going to want to pick out 2 points, and then you're going to want to find the rise over the run of those 2 points, and then always make sure to decide if it's positive or negative, so that you get the right sign. If it's increasing from left to right, it's positive. If it's decreasing from left to right, then it's negative. Okay, good luck, and we'll check your answers here in a second. Okay, here we go. I'm going to pick out 2 points. I'm going to pick out this point right here. That's at -1, 0, and it looks like the next point's right here. So the rise is up 2 over 1. 2 over 1 is 2. That makes sense because it's a positive slope. Good. Let's pick out another point here. It looks like it crosses right here, and it crosses right here. So this is rise 1, and run 1, 2, 3, 4. So the slope of that one is 1/4. Okay, number 3. Ooh, horizontal line. Horizontal line. Horizontal lines always have slope of 0. So don't forget that. Horizontal lines always have a slope of 0. Number 4. Let's pick out a point here. I'm going to pick out this point, and I'm going to pick out this point. So let's find out. I got my rise over run. My rise is going down 1, 2, 3. So my rise is -3 over my run, which is 1, 2, 3. So -3 divided by 3 is -1. So -1, and that makes sense because the line is going negative. It's going down from left to right, so it's negative slope. Okay, let's pick out another one here. Number 5, I'm going to pick out 0, 0. That looks good. I'm looking for an even place where it crosses. It looks like it crosses here. That's good. So my rise is 1, 2, 3. Rise is 3, and my run is 1. 3 divided by 1 is 3. Okay, number 6. Ooh, a vertical line. The slope of a vertical line is always undefined. Or you could have said infinite slope as well. Either one of those works. Okay, nice work. Now, I'm sure you've gone somewhere on a long trip or something where you've ended up coming across a sign that talks about a grade. Steep grade ahead. Warning. For example, I've gone to Donner Summit, which is in California, going over the big pass there, and there's some pretty steep grades there. There's steep grades all over, especially when you're traveling in mountain areas. Grade is another word. It's actually the real life word for what we call slope. We've been talking about slope in this lesson. In real life, when talking about road travel, slope, we actually call it as a grade. And so we want to talk a little about the idea of a grade and talk about how we can calculate that in this class so that we can give it some real life application. So, grade, again, is just another word for slope. It's rise over run, but it's important to remember that grade is always written as a percent. as a percent, as you see here in this sign, grade of 15%. So we're simply going to do the rise over the run. So let's say a truck travels 1,200 feet in the horizontal distance, and during that time, it increased in altitude 150 feet. Can you find the grade of this road? So simply, you would just do, again, rise over run. That's what slope is. That's what grade is. It means the same thing. Rise, we rose 150 feet. We then ran to 1,200 feet. And again, we would just do, the feet cancel out here, and we just have 150 divided by 1,200. And if you type that into your calculator, 0.125, which is 12.5%. Remember, grade is always written in a percent. Okay, so let's have you guys try a grade problem. Here is, let's say you're doing a little off-roading in your green Jeep. Yeah! Woo! And let's say you're going up, I don't know, going to some place where it gets a little crazy during a 1,500 foot horizontal distance. You rise 300 feet in altitude. Your goal here is to find the grade. Go ahead and pause the video and see if you can calculate the grade, and then unpause it and we'll check your answer. Okay, good. Grade is just rise over run, 300 over 1,500. This fraction actually simplifies to 1 over 5, which comes out to be 0.2, which is a 20% grade. That's a pretty steep grade. Most grades in the United States don't usually exceed 10%, maybe in some places you get a little over that, but not very often. Especially on like big roads, they don't get very high because those diesel trucks, they don't do very well on grades. Okay, well that's it. That is the lesson for today. Thank you for watching, and you can continue on to the assignment.